Hello everyone, welcome to pyrevise. Now we are going to talk about classes. So what is classes? Classes is a template, a structure which constitutes of data attributes and method attributes. Saying in simple words, it's a format, a structure which has your variables and your methods. So this is a syntax for class. Starts with the class keyword, then the class name, then in brackets you have the base class name. Base class name is a class which you inherit, and there is a doc string and class level variables. And then you have your constructor, which is init method in Python, then instance variable. So you can see there is a self variable here. Self stands binds class to the instance. Then there's a method, class method, then self, then method parameters and method statements. And we'll take an example of test class which inherits object. This is a new style class definition. We'll talk about new style a little bit later. Then this is a doc string. This is a class level variable. Then there is an init method. This is a parameterized init method. As you can see, name as a parameter we are taking. Then there is an instance variable. It's a print statement, test method, method variable, and another print statement. So in Python, all the class level variables are considered static. There is no separate static variable definition. All the class level variables are considered static in Python. Now we'll take the same example. Here, this is a test class, inherits object, class level variable. Here we have a class list as an added class level variable. Then this is constructor or init method and a test method. Now we'll initialize test class with a T1 instance. So once we initialize, init method gets called and it prints test class init and it initiates the instance variable. Now we will see the variables. First, the class variable gets printed. Then we call the instance variable. So it gets the value T1 instance variable, that instance name and instance variable. Now we'll initialize T2. There is another instance of test class. Again, test class init method gets called. We access the class variable, which is same. Then the instance variable. So we get again instance name, instance variable get initialized. Now we'll see the test method from T2 gets called and test method gets called. It prints the test method. Then we'll see the class list, that is iterable variable. So in Python, as everything is called by reference, the class list refers to the same memory location and it's shared across all the instances. So these class variables are shared by all the instances. So we'll see how that happens. As we see, it will refer to the same ID. So T2.classList, it's 1, 2. Same way, T1.classList is 1, 2. Now what we'll do, we'll append to class list 3. So it becomes 1, 2, 3. And we did it using the T1 instance. Say now, if you access T2.classList, it also got changed. So this way, all the class variables, which is iterable, are referencing to the same memory location. So this class variable, just keep in mind, class variable, which are iterable class variables like list now, they are shared across all the instances in Python. Now there is a consideration. So any variable which is prefixed with underscore should be treated as private variables in Python. There is no specific private variables in Python, but this is a consideration that any variable prefixed with underscore should be considered as private. Then talk about inheritance. Let's define a class first. Class A, which inherits object. So when we do a new style, class definition in Python, we inherit object. So Python understand from Python 2.2 onwards. In Python 3, everything is new style objects. But if you are using 2.x, you should inherit object. So it becomes a new style class definition. So what is difference here? So first, there are so many, But first, if you take a type of class A initialization, it shows in old class, it shows type instance. In new class, it shows class main A. So by this, you will understand is the old class or new class definition. In old class, you don't have to inherit object, just class A. It will take you to old class definition. Now we'll come back to inheritance. We'll define another class B which inherits A as init and a child method in it. Now we'll initialize class B with B1 instance. So once we initialize it, it prints initialize the init method and prints I am class B. Then we are calling child method, so it prints I am child B. Then we are calling parent method, so it calls the parent method from class A as class B is a child of class A, so it prints I am parent A. Now we will define another class C, which is a child of A. It has init constructor, that is our init method, parent method and test method. Here it overrides parent method from the parent class. So this is a method overriding or function overriding in Python. Now we'll initialize class C, C1 instance. So when we initialize class C, it prints I am class C using initialize init method, then test C, that is test method. So now we are calling the parent method, which is overridden method. So it gets prints I am parent C. So it calls method from class C, which is overridden method. Now we will define another class D. Class D inherit both B and C. So it has init method and call to a super to its parent and then a child method. So super is introduced in new class object. It is not present in old class objects. So now we will initialize D1. So once we initialize D, we will get I am class D from init method of class D, and there is a call for super. So it prints I am class B because B is first parent of D. Then we are accessing the MRO variable. This MRO variable shows us how inheritance or how search path for inheritance will work. So first class main D, then class main B, then class main C, then class main A. So it's breadth first search. In old class definition, it was depth first search. So in new class definition, you have breadth first search. So first, when it traverses, it goes to D, then B, then C, and then A. So when we call the parent method, it will search it in B first. It doesn't find, then it will search in C. So first child D and then the parent C. So it searches in C class. So we get parent C, and then again we call the test method, which is from its parent C. So this is how whole inheritance works in Python. Now we'll see exception handling. What is exception? Exception means an event which interrupts your program. So in Python, we use try except block to catch exceptions. So in try we have print dir. So dir is a method which prints the module attributes for us, then name, the module name and module file. And we are catching if there is an exception. Exception is a base class for exceptions. So here, as there is no any exception, it prints dir, then name and the file name. Now what we will do, we will introduce an exception or an error. As a name, we remove one underscore, we get an error, that is a type name error. So at type name error, what we will do, we will add except block which catches name error, then we will add the general exception catching block. We can have multiple except blocks for catching multiple exceptions in Python. So now what happens, the name error blocks catches the name error exception and it prints error name is not defined, the name error gets printed. So for in exception, you can general syntax of except block is except, then the exception class name adds e, and then you can use the e variable to get it a type print your exception. Then there is, we are removing the exception, making it normal. Then there is a optional else block. So when there is no exception, this else block will work in Python. So as you can see, as there is no exception, dir name file gets printed, and then else block executes as no exception, and we have finally. So try, except, and finally. This is a basic syntax of what finally does. So finally, if there is an exception or there is a no exception, finally will execute. So when, if you want in your program, if you want to do something when there is a no exception, use the else block. Or if there is an exception or no exception and you want to do something, use the finally block. So this is whole output will look now. dir name file else block executes, and then the finally executes. Now if you want to raise an exception, you can use the raise keyword. So I am raising a name error here, so you can use any exception using the raise keyword. And also Python supports user defined exception. So for user defined exception, you have to inherit the exception class, and you can create your own exceptions in Python. This is all about classes in Python. Thanks for watching.